I'm going to start recording and sharing my screen. And so today we're going to look at interest. We're probably going to focus on simple interest. Homework 20 is that homework that is on just percents. And homework 22 is the homework that's on simple interest. There will be no class on Friday. Again, I have to attend that state meeting. And I'm thinking what I forgot to add here is that project 3 is due on, I'm thinking I said the 13th, but for you guys, was it the 12th because the 13th is a Tuesday?
I think so.
Okay. All right. Thanks, Mackenzie, for letting me know. Any questions on any of that? Or does anybody want to look at any questions in the homework? Also, hopefully, before the end of the day, Monday, everybody took that test. If you submitted work in Blackboard, I looked at that and graded it. If you didn't submit work, I did not pull your grade from my labs into Blackboard. If you did not take it, please get in touch with me before the end of the day today. But beyond that, homework-wise, does anybody have any questions? How are you guys doing with that percent stuff? Not hearing any questions. I'm going to go on the assumption there's two possibilities. One is nobody started it, and so they don't have questions, and the other is everybody started it and doing well, and they don't have questions. I like to assume it's the latter, but if you do have questions on it, please don't be afraid to use the Ask My Instructor, and don't be afraid to attend my office hours or send me an email or ask for me to meet with you outside of class time. Which reminds me, I have to tell everybody that because I'll be attending that meeting, I'm going to cancel my office hours on Thursday and Friday too. So I'll let you guys know now. I'm also going to have to cancel my office hours on Thursday and Friday. Today we're going to start looking at interest. And we're going to most specifically look at simple interest today. We'll start looking at compound interest next week. Am I correct in assuming that everybody's heard of interest?
Yeah.
Yeah. What is it? You've got a loan, if you've got a credit card, you pay interest. If you have a savings account, it might not be much, but you earn interest. I look at interest as a price paid for using somebody's money, for using money. You pay interest on a loan. When you borrow somebody's money, you have to pay extra interest. It's like a fee for having used it. You earn interest on savings or an investment. And that's because when you invest or make put money in a savings account, the bank actually uses your money. And so they're paying you for the privilege of using your money. Interest, the rate is usually expressed as a percent, which is why we spent so much time looking at percents last class, because we need to be able to work with percents in this consumer finance chapter. So it's usually expressed as a percent. Again, today we're going to focus on the idea of simple interest. And is everybody all right if I add a page? I'm sorry, I couldn't hear if that was okay or if you needed a little bit more time.
I'm good, thanks.
So today we're going to focus on simple interest. And with simple interest, there's certain variables that we use. I is going to be the amount of the interest. And by that, we mean the dollar amount. R is going to be the interest rate. It's going to be a percent that we have to express as a decimal. T is going to be the time, and it's usually in years.
So aren't these little variables part of an equation? Isn't it like I equals P RT? So like
Yeah.
percent times rate times time.
You got it. And P is the principal, which is the starting value. Which would be the loan amount if we're borrowing. Or it would be the investment amount if we're earning interest. And just like was mentioned, when we look at simple interest, they're related with the formula I equals P R T, which is saying that depending on how much algebra you've taken, hopefully everybody's familiar when the variables are written next to each other without a symbol in between. Is everybody familiar with the idea that that means I'm multiplying? So that tells me that the interest is equal to the principal times the rate as a decimal times the time in years. Now, I'm going to ask you throughout this chapter, we're going to have a lot of formulas. When you do these problems, I'm going to ask you to first write the formula. Then the next thing that I'm going to ask you to do is identify your variables. Then I'm going to ask you to show your substitution into the formula. And then lastly, I'm going to ask you to show your answer. A little bit later, we're going to see an example where sometimes in between here, you need to solve an equation. So let's look at a couple of examples. Does everybody have all of this down? So my first example, I'm going to invest $10,000 at 5% interest You know what? I started writing the wrong example. Do you guys mind if I skip this one for just a minute? I need the one above it first. Let's say we want to borrow $2,400 for 2 years at 7% simple interest. What's the interest owed? And so with this question, the key words are simple interest. If I'm dealing with simple interest, it will be that formula I equals P R T. So again, with these problems, the first thing I'd like you to do is write the formula down. We're going to find that there are a lot of formulas this chapter. For the most part, you won't have to memorize them. There will be a formula bank, a formula sheet. I will email it to everybody before the end of the day today and also post it into Blackboard. We're only going to be looking at a couple of them today. But first thing I want you to do is write the formula that you're using because I want to see that you're picking the right formula. Then to identify our variables, we're going to have to say what P is equal to, what R is equal to, what T is equal to, and what I is equal to. Again, P is our principal, it's our starting amount. It would be our loan amount. So is everybody comfortable with this problem, P being $2,400?
Yeah.
R is our rate, it's 7%, and you can write the percent, but it's very important that you convert it into a decimal. So 7% would be 7 out of 100 or 0.07. Our time needs to be in years. And here we've got that the time is 2 years. And the interest is what we're looking for. And so again, I want to see that you're putting the right number in for the right variable. Then I'd like to see you substitute into the formula. I is what we're looking for. For P, we'll put that number 2,400. For R, we'll put I'm going to put parentheses around to show multiplication, 0.07. And for T, we'll put 2. And so that's the substitution. And now we're going to just type that into our calculator, 2,400 times 0.07 times 2. And doing that, can you tell me what you get?
336.
And so our interest is $336. Did everybody get that one?
Yeah, I did too.
Great. I'm going to put the next one on a different page, and this was the one that I accidentally started too soon. Next example, let's say we're going to invest $10,000 at 5% simple interest. But this time we're doing it for 8 months. We want to know how much interest is earned. Again, we don't have much to work with, but keep in mind those words, simple interest, tells us we're going to use that I equals P R T. I is what we're looking for. So we need to substitute in for P, for R, and for T. What's our principal this time? What's our starting amount?
10,000.
$10,000, great. Our rate is 5%, but again, we need to write that as a decimal, 0.05. And here we have to be careful because the time is supposed to be in years, but what we've got here are 8 months. Pay attention to the unit, the fact that that's months. Is 8 months more than a year or less than a year?
Less than a year.
Less than a year. And so our we're going to have a fraction of a year. How many months are there in a year?
Well,
12. So does it make sense that 8 months would be 8/12ths of a year? If you want to, you can reduce that fraction. I know some people like to change it into a decimal, but be careful. Sometimes when you change them into a decimal, you get a repeating decimal, and we don't want to round off too soon. So quite honestly, because I don't want to make a careless mistake, I'm not even going to reduce that fraction. I'm going to leave it as 8/12ths. So when I substitute, I'll get I equals 10,000 times 0.05 times 8/12. With my calculator, I'm going to type that in as 10,000 times 0.05 times, and then for the fraction 8/12ths, I'm going to just put 8 divided by 12. And when I put that in, let's find it to the nearest cent. Is anybody else getting $333.33?
Yeah.
And again, if you would have rounded that sooner, you would have been off because of rounding errors. So again, don't worry about changing that fraction to a decimal or simplifying it. If you want to, you can put parentheses around that, but with most of these, it's not really essential that you do so. Next example. Let's say we borrow $1,000 at 6.5% interest. I'm sorry, I left out a word, simple interest. For 60 days. How much interest do we owe? And again, those words, simple interest, tell me I'm going to use my I equals PRT. P, the principal, what would you folks tell me it is with this one?
1,000.
Our rate is 6.5%, but be very careful changing that into a decimal. We move that decimal 2 places, so we get 0.065. And again, our time, well, 60 days is way much less than a year. With these problems, Mr. Blitzer in this book uses a banker's year.
So it's going to be 5 years, right?
No, a banker's year is 360 days.
Oh, by days. Okay.
Okay. And so here, well, most people think of a year as being 365 days. It's been tradition for a banker's year to be considered 360 days. anybody's ever taken our business math or our consumer math class, you'll find with these, there's two types of problems, one using a banker's year and one not. I think it kind of became 360 back in prehistoric times, before computers, before calculators, because computationally 360 was an easier number to work with. And so here, if I have 60 days, it's only a fraction of the year, and that fraction would be 60 out of the 360 days that are in a banker's year. So if you have months, you'll put it over 12. If you have days, you'll put it over 360. And so that gives me, substituting, my interest is my principal, $1,000, times my rate, 0.065, times my time, which would be 60 over 360, or 60 divided by 360. And so put that in your calculator and tell me what you get to the nearest cent.
Should we use the parentheses or no?
You can if you want to, you don't have to. You could just type that in as 1,000 times 0.065 times 60 divided by 360. I use the parentheses instead of the X's when I write it, because since we're using variables, I don't want anybody to confuse that X for multiplication with the variable X. And so to show that they're being multiplied, I put them in parentheses when I write them. But when I type them in, I don't use those parentheses. There will be places in other formulas where it's really important that we use parentheses, but this one, because there's no parentheses in the formula as it's written, they're not necessary. So to the nearest cent, what are you guys getting?
I got 10.83.
Yep, $10.83. Great. And so far, is simple interest all right?
Yeah.
Then next thing we're going to talk about beyond simple interest is something that's called the future value. And the future value is the sum of the principal and the interest. Mr. Blitzer uses an uppercase A for future value. And so based on what we just said, if we know the principal and the interest, the future value is the principal plus the interest. If we don't have the interest figured out already, we get that the future value is the principal plus, well, the interest we said is the principal times the rate times the time. Usually, instead of writing like this, you see this written, if you know the distributive property, we're going to undo the distribution. If you're familiar with algebra, what we're doing is we're taking out a common factor. But that formula is equivalent to the principal times the number 1 plus the rate times the time. And so on the formula sheet, this is the way it's going to look for future value. This is the way I'm going to write it and use it. And with this one, these parentheses are important, and we need to type them. And so this will be the formula for future value with simple interest. So next example, let's say we invest $2,040 at 7.5% simple interest. At this point in time, I have to apologize because I'm using the interest rates comparable to what Mr. Blitzer uses in his book. But those problems are dated. They've been around as long as I've been using the book, which is 15 years. And in the past several years, interest rates have been brought way, way, way down. And so you usually don't see interest rates that high on savings anyway. On loans, sometimes yes, but on savings, not so much so. Usually, I think now you're lucky to even just earn 1%. But we'll be optimistic and say we can get this higher amount. So we're investing that $2,040 at 7.5% simple interest for 4 years. What's the future value? Again, keywords, I need to remember that this is simple interest and I want the future value. So when I look at my formula sheet, the formula I will use is the one that's above. A equals P times 1 plus RT. P is the principal, R is the rate, T is the time. In this instance, our principal is 2040. Our rate, 7.5%. We write as the decimal 0.075. And our time roughly is in years, so it's just 4. Is everybody comfortable with showing that work so far? And again, I ask that you please, when you're showing me your work on a problem, write it down in this way. Then substituting, I get A equals, for P, I'll put the 2040, pardon me, dollars. Then I'm going to multiply it by, I need to open that parentheses. That's the number 1 plus my rate is 0.075. And I'm going to multiply it by 4, close parentheses. With this one, in a calculator, I would first type in my 2040, then I'd use the multiplication. Then I'm going to open parentheses. I'm going to type 1 plus 0.075 times 4. Then I'm going to close my parentheses and cross equal. I know sometimes people don't put this multiplication symbol in front of the parentheses. With a lot of calculators, it's not needed, but I do remember that there's some brands where you do have to put that multiplication in. And so I think it's easier to err on the side of caution and show that we know we're multiplying. Because if you use the multiplication symbol and it's not necessary, you'll still get it right. As opposed to if you don't use it and your calculator needs it, then you'll get it wrong. And so as I go through and work this out, let's see, I'm taking 2040 times parentheses 1 plus 0.075 times 4, close parentheses. I get that my future value is
$26.52.
$50. So far, so good.
Yeah.
Now, once we've got the future value, if I'm asked how much interest is earned, well, the interest is always going to be the difference between the future value and the starting amount or the principal. So we're not going to really treat that as a formula, but rather we're going to use that as a concept that we want to find the interest. If we know the final amount and we know the initial amount, it's just the difference. So if I take that 2,652 and subtract that 2,040, the interest earned is $612. Is everybody all right with that?
Yeah.
And a couple variations on this future value theme. You sometimes see questions that say, I need $2,150 in a year. I have $2,000. At what rate? Simple interest. Do we need to invest? Do I need to invest? Now, with a question like this, you have to pay close attention to the wording. Oh Lord, I misspelled interest, I apologize. We know it's simple interest, but now we've got two formulas for simple interest. One to just find the interest and one that involves the future value. So let's look at what we have. This $2,150, is that the money I have now? Or is that the money I want in the future?
In the future.
It's in the future. And so everybody needs to recognize it, that this phraseology is talking about the future. So then this $2,000 that I have now, that's going to be my principal. And so I'm looking into the future. I need to use that future value formula. I know the future amount is the 2,150, so that'll be my A. I know the principal is the 2,000, that'll be my P. I know that time is 1 year. And so this time it's the rate that I'm looking for. So when I substitute into the formula, I get that the 2,150 is equal to 2,000 times parentheses 1 plus R times 1. So again, to have gotten to this class, it's assumed you have a little bit of fluency with algebra. What I would do first is simplify. And so R times 1 is just R. So that gives me the 2,150 is equal to 2,000 times 1 plus R. Now we're trying to solve for R, which means we're trying to get R alone. Because they're not like terms, I cannot add them. And so from this point, have all of you heard of the distributive property?
Yeah.
When I've got a variable in parentheses and I want to get it out, I need to distribute or multiply everything in the parentheses by what's on the outside. 6 and get the 2,150 equals 2,000 times 1 is 2,000 plus 2,000 times R is just that, 2,000 times R. Now, when I try to solve, when I solve an equation, I always think that what I'm really trying to do is get that variable alone on one side. In order to do that, we have to kind of undo things, work backwards, and we have to remember whatever we do to one side of an equation, we have to do to the other. It's like a balance. And so before I get the R alone, I want to get the R piece alone. 2,000 is being added to it. The opposite of addition is subtraction. So I'm going to subtract 2,000. And again, what I do to one side, I have to do to the other to keep it in balance. So that gives me 150 is equal to 2,000 times R. And again, when that 2,000 is written next to the R, I'm multiplying. To get the R all alone, we have to undo multiplying by 2,000. And the opposite of multiplication is division. So I'm going to divide both sides by 2,000. Give me a second. Okay, he did get in. I wasn't sure somebody was in the waiting list or not. And so now when I take 150 and divide it by 2,000, what do I get? So that's
0.075.
0.075. And so that's my rate. But again, the rate we want to express working backwards as a percent. And so we'd need a rate of, moving the decimal 2 places, 7.5%. And you see, we're using that same future value formula, but if we're not just looking for the future value, but know the future value and we're looking for something else, we end up having to solve an equation. I think we have time for another example like that. Let's say we need $6,000 in 4 years. How much should we invest now if I can get 8% simple interest? Now, here again, we need that $6,000 in 4 years. It's not what we have now. And so that tells me I'm looking into the future. Where I'm looking into the future with simple interest, I'll use that future value formula, A equals P times 1 plus RT. We've already decided that that 6,000 is not what we have now, but what we want in the future. Going through the sentence, I think the next thing is clear that our time is 4 years. And our rate is 8%, which would be 0.08. What we're looking for is what we need now. So P is what we don't know. Now, before we go through and find P, we need to say that if we're looking for P, to solve for P, the very last step, you always, if you have to round, round up. We're not going to necessarily use regular rounding rules, but we're always going to round up, because if we round down on our principal, at the end of the time, our final value will be rounded down and we won't have everything we need. So rule of thumb, when you're solving for the principal, you're going to see that the question asks you to usually, it says to round up, because if, again, we round down, we won't have enough. So let's go through and let's find it to the nearest dollar. So substituting this time, A is my 6,000. P is what I'm looking for. And in the parentheses, I have 1 plus my rate is 0.08 and my time is 4. This time, I'm not going to distribute because I'm looking inside the parentheses. And does everybody remember from somewhere in your mathematical career, you're supposed to, if possible, simplify inside first. If you can. And so I think we can take type into a calculator 1 plus 0.08 times 4, and we'll get 1.32. And so we get that 6,000 is equal to 1.32 times P. Is everybody all right with that?
Yeah.
Then we're multiplying P by 1.32. We want to undo that multiplication in order to get their P alone. The opposite of multiplication is division. So let's go through and divide both sides by 1.32. And my calculator gives me $4,545.454545. Repeating. I want it to the nearest dollar because this is not a 0. Again, I want to round up. So that gives me $4,546 that I would need. Any questions on that? Everybody okay?
Yeah.
Yeah.
Okay. So you guys, without asking questions, this was what I had on the agenda to complete today. Next, we're going into compound interest. And I really don't want to start that today if we're not going to be picking it up again until Monday, because we don't have much time to do anything other than throw out a couple definitions. So, does anybody have questions on anything? If not, we don't end early very often. We're about 5 minutes early, but I think there's probably plenty of times where we've run over a minute or two. That it kind of all balances out in the end if we finish early every once in a while. Before we do anything, Bianca, you came in a little bit after class started.
Yeah, sorry.
And Alan, you also came in a bit after class started. Is there anybody else that I missed on attendance?